Right, so Joy, I'm from Kenya, Ethiopia, and registered at KCMC. I thank the previous speaker for such an emotional talk, and I hope we also get a bit emotional about the things that I'm about to present now. So I'm going to give you an overview of the work that I've planned for my PhD in northern part of Kenya. It's about tick-borne diseases. We just started the work towards the end of last year, so I'm just going to give you an overview of why we are doing the work and the kind of things that we expect to get from the work. Now, as a background, ticks are mostly classified into two groups. We have the hard and soft ticks, and now the hard ticks are the most medically important. And ticks are considered to be just close to mosquitoes in the terms of the number of diseases that they transmit. And this is a bit political right now because a lot of diseases that ticks transmit keep on increasing with increasing technology in this area. The most medically important diseases are the arboviruses, and the ticks are so good at transmitting these diseases because they feed on a wide array of hosts. Basically, any living organism that has blood will be attacked by ticks. Now, in the transmission cycle for the arboviruses, there's in a classic situation, you'll find that there's preparedness in terms of when there's constant surveillance and animals are vaccinated, so then there's a chance to get an early detection, and the response will be in time before the diseases are transmitted into human populations. But what happens in most cases is there is always no active surveillance of these diseases, and in most cases we only get attracted to or get attention to these diseases when we get the first human case. And some of the reasons that could be due to this is because we don't really understand much about the ecology of these diseases, and this delays the preparedness. This is what is informing the basis of my research. Now, specifically to Kenya, a lot of work that has been done in ticks in the pastoral communities has detected a lot of diseases, but it's really not clear how the activity of the diseases in a network where you have the livestock migratory routes and you have the pastoral communities, and how the diseases move, because these are people who constantly move with their livestock in search of pasture. So it's really not clear how the tick and the disease interact in such situations. And it's also not clear if there are other undetected pathogens that are being transmitted in these regions that we just not, our attention has not been attracted to. Now, again, for one of the very dangerous diseases that is being transmitted by the tick is the CCHF. There are a lot of research that is right now going into this, and for CCHF, you have once a tick is infected by this virus disease, it maintains the disease throughout its life cycle. And when the tick then bites a human being, then they cause the infection. But the other ways that the infection can also be transmitted to the human being, such as the contact with an infected tissue, which is mainly happening to healthcare workers in hospitals. Now, in the past, there's been a lot of CCHF outbreak that is reported worldwide, mostly in Europe recently, and even closer here, there's been a lot of cases in Uganda, especially on the eastern part where it borders Kenya. But in Kenya, there has also been a lot of reports on seroprevalence of this disease. But what we really wonder is, why has there been no outbreak in Kenya of this disease? We kind of postulate that this could be a difference in strain viability. So the strain that could be circulating in Kenya could be the less virulent strain. And there's some evidence that difference in strain could affect the virulence of virus. Now, when we look closer into the strain of the global diversity of CCHF strain, there's really no information on the strains that are circulating in Kenya, and this is one thing that we've decided to bridge this gap and provide information on the strains that are circulating in Kenya. How we are going to do this is we are actively collecting ticks right now, and after collection, then we just do a species ID of the ticks and try to correlate them from the sample sites. Then we have also collected human serum samples from 4 counties in Kenya. What we're going to do with this is to look at the exposure to the CCHF virus by use of IgM that will tell you recent exposure, and IgG which gives you some years of past exposure. Then for our serum samples, we are also going to use molecular methods to detect rickets infection. And for the tick samples, we are going to use a combination of metagenomic sequencing and cell culture to isolate the viruses. For the CCHF, we are going to do a whole genome sequence of the isolates that we'll be getting, and then this will be mapped onto the global CCHF strains that are available in databases. What we expect from this is to have a good insight into viral strain variability in Kenya, and probably try to answer why there has been no outbreak despite the constant detection of the virus. We also hope to provide a good profile of the tick-borne arboviruses that are circulating in Kenya, and also give some overview on the minimum exposure rates of these ticks. Thank you.